Good afternoon, class. In today's video, what I'd like to do is to go over an example problem from the density problem set that is in the gas laws example problems video series that I've been doing. So for this one, we're going to go over the equation for density. Density being rho equals m over v, or density is mass over volume. I know this looks like the letter P, but it's actually the Greek letter rho, so something to keep in mind. So in this case, if you want to follow along, we're doing number 18 and number 19 in the density problem sets. This is the second set. The reason why I did it was because if I do this problem, I believe I've covered what is how you should do numbers 1 through 15 in the other problem set. So this one I feel like this should work. At least in terms of how to solve all of the other problems from the other homework set. So I don't have to reshoot more videos on this. Not that it's not necessary. It's not that I don't want to. It's just that it wouldn't be necessary to get the idea just from, if I can do it in one video versus two videos, it's better. So we take a look at, we have our equation here, and the problem stated that I have a material that has a density of 200 kilograms per cubic meter. It has a mass of 100 kilograms, so how much volume does it take up? So that's what I wrote down over here. I said my density was 200 kilograms per cubic meter. The mass was 100 kilograms, so what would the volume be? It would be that's why it's a question mark, in cubic meters. So what I do, like I've done in all the videos on this series, I'm going to substitute the given values. I'm going to solve. So I'm just going to substitute all my values. Rho is 200, mass is 100, v is we don't know. So there we go. Now if you notice, like I did in my last video, I chose the problem that had the variable in the denominator so that you get a little bit of extra practice in seeing how that is dealt with. So in this case, what I'm going to do because again, I could just simply invert both of these, invert both of the fractions, and I would have a much easier time solving this. But I didn't want to do that this time because I want to show you the technique. So what I'll do first is I'm going to try to isolate v as much as I can. So now that's being 100 is in the numerator. I'm going to try and move that 100 to the left side of the equation. So in this case, 100 is in the numerator, so I have to divide by 100, but instead of dividing fractions by fractions, instead of doing that, which I have a video on earlier, what I'll do is I'll multiply by the inverse of it. So now I've got 100 over 100, and 100 divided by 100 is 1. So that's great. So now we do the same thing to both sides of the equation, multiply by 1 over 100. So that becomes 200 over 100, which is 2, and then we've got 1 over v. Now, here's the thing. I want v on one side of the equation, and I want it in the numerator. I don't want it in the denominator. So what do? I'm going to now multiply both sides of the equation by v, so that now I've got 2v equals 1, and v equals 1/2 cubic meters. What you may have noticed is that this is fully featuring the shortcut method. So in this case, I didn't put any units in here. I just assumed that my answer was going to come out to the correct units, which is cubic meters, and so I went along with that assumption. Now, if you're really good at this, this is fine. Especially if this is not the first problem that you've done in the set, this is a perfect method to do because you know what's happening. You know how the units are being played out, so it's fine. But if this is the first one, let's say this is the first one in the problem set is number 18, so I wouldn't do this for number 18. I might do this for number 20 in that homework set, just because this method doesn't show you that you're completely correct. You assume that all of the units work out to get you this number, or to get you this answer, but it may not. Maybe something's wrong in how you in all of your steps, and you would only catch that using the units. So not recommended for the first problem, but for the second, third, and fourth problem, yeah, it's fine. Mostly because, and I hope what you're noticing throughout these series of problem sets is that I'm kind of just taking the equation, let's say rho equals mass over volume, and I'm just changing density, and I'm just changing mass. I'm just changing those numbers it's the same equation, the same mechanics are there. I hope you're noticing that, because that's kind of the point. I want you to practice this equation. So I want to give you some problems that have a very specific goal in mind of just practicing and getting comfortable with that form of the equation, solving for that specific variable, so that when you go to the next one, you know, it's not something that's like new or something that you've never seen before. It's things you've seen before, so that you're comfortable with it. So when we take the test, you're not surprised. And because that's really not, because the test is never the time to be surprised. Homework is the time to be surprised, because that's when you can work on something, you figure out, oh, this is exactly what I don't understand. That's the time to experience that frustration, because test time is test time. You have to just be able to answer the question. So that's why I structure the homework like this. And so, you know, when you work through all of this, you get the answer of 1/2 cubic meters. That's great. Now we go on to, as your bonus problem, we get to number 19, which says, what real life material actually mimics this? So there is no, like, I believe the question specifically says element, but what I'll tell you in this video is that if you can't find necessarily a specific element that can do that, that's always nice, but if you can't find it, a material is fine. So the closest one that I could find to this 200 kilograms per cubic meter in terms of density is liquid methane at -90 degrees Celsius. So if you found something that's exactly 200 kilograms per cubic meter, that's great. I mean, you should definitely write that answer down. But from my research, all I could find, the closest one was liquid methane, and that was that was only 196 kilograms per cubic meter. So, you know, if you find something closer, that's great. If you don't, you know, if that's the best answer you've got, it's fine. And that's why I say that on this video, so that when you watch this and you actually do the homework, well, there you go. You know the level of answer that I'm expecting, because otherwise you'd probably be going nuts trying to find something that has exactly this density, and then you may not even find it because it may not actually exist. So I didn't want to, you know, burden you with that. So that's why I did this example where I could say, well, it's close enough. You know, so that's how to do problems number 18 and 19 in the second density problem set. This should also cover pretty nicely how to do numbers 1 through 17 in the other problem set. So good luck in your studies, and may the force be with you.